Hello world, it's Siraj, and healthcare is the most exciting application of AI technology. Using AI, we can cure all major diseases, help doctors treat more patients, and even enhance our own cognitive abilities to superhuman levels. The School of AI just announced its first global hackathon called Health Hack at a launch event in Singapore's National Gallery. So I flew to Singapore to give a keynote on AI in healthcare at the event, as well as attend a panel discussion on the same topic. In this video, you'll get to see exclusive footage of that keynote and the panel discussion. I hope you find it educational and inspirational. And if you're new, subscribe to get notified when I release my videos. Enjoy.
Introduce you to Suraj Raval. He's the founder of the School of AI, as I said, an international nonprofit with the mission to offer a world-class education in AI to anyone on Earth for free. Suraj's YouTube channel of AI education content has over 500,000 subscribers, and he partnered with Udacity to launch their Deep Learning Foundations Nano Degree program. Besides being an AI educator, Suraj is also a best-selling author, public speaker, data scientist, contributor to open source projects like OpenAI, and rapper. So, please join us in welcoming Suraj Raval.
Thank you, everybody. Thank you. Let's see how loud this mic is. Okay, perfect. Good, very good. Okay, I'm very excited to be here in Singapore. Yesterday I flew in from Los Angeles. It was a 17-hour flight. So I'm here for a reason. I believe in the people here. I think we can do a lot of great things. This community here in Singapore can do a lot of great things for healthcare. And so in this talk, I'm going to talk about AI in healthcare. Specifically, I'm going to talk about AI in drug discovery and a few other applications. So I'm going to list 3 applications, my thoughts on them, and then we're going to talk about, for each of these applications, how this would work using technology. We're going to get into specifics, okay? So before I start, I want to talk about what I'm most excited about. What I'm most excited about is the convergence of biology and information. So if we think about it, the byte, the gene, and the atom. Let's just think about that for a second. The byte, the gene, and the atom. These are 3 fundamental building blocks for 3 different subjects. The byte for digital information, right? From the byte comes kilobytes, megabytes, and then programs and algorithms and everything else, data. From the gene, you know, we all have DNA, genetics. A lot of it makes us who we are, our traits, what we're into, how we think. A lot of that comes from genetics. And so biology, from DNA, from genetics, springs life. And the third is the atom, so matter, right? A lot of amazing innovations have come from matter. And so in the 20th century, we saw a lot of incredible innovation segmented in each of these fields. So in biology, we saw revolutions in healthcare in terms of cures for new diseases and ways of dealing with genes such that we can create new gene therapies, different things like that. When it came to the byte, I mean, I don't even need to explain all that's happened in computer science in the past 5 decades. And then for the atom, you know, physics, geophysics, I mean, earthquake prediction, there's so much there as well. So that's what defined progress in the 20th century, these 3 fundamental building blocks, and specifically how we humans use those to make innovations. But I'm here to say that in the 21st century, where we are right now, what's going to define progress is the convergence of these 3 fundamental building blocks. So the one convergence in particular I'm very excited about is the convergence of the byte and the gene, of information and biology, because of computer science, because of data, because of algorithms, we have so much biological data that is now available to us. You know, I just had a test done and I had blood drawn and it was like these 3 vials and the lady was taking it away. I was like, hold on, I want that data. She didn't even understand what I was talking about. Like, these 3 fields are segmented, they're separate, but they need to converge because my blood has so much data I want to know about myself and what I'm into, how I can optimize my life better using what's built into me, like what types of food I should eat, what types of activities I should be doing, what types of climates I'm best suited for, things like that. And algorithms, information can help approximate those solutions. But that's just one example. We have several coming up. So I just wanted to give you a kind of base frame of thought as we go into this AI in healthcare space. We got to be thinking about the convergence of the byte and the gene in particular. And that's what AI in healthcare really is. So first application is drug discovery. So specifically in the US, it takes about 10 years for a drug to come to market. And it takes tens of millions of US dollars. And so that is, it's generally long wherever you are in the world because of different regulations, and that's just how it is. That's just how it has to be. It's not like some nefarious plot. That's just how it is because of the process of having to select the best candidates for some treatment for some disease. A lot of molecular biologists and people working in cancer therapy, they have to pick from 11 million plus candidates for what could be the ideal cure for whatever disease they're trying to tackle. And roughly they're doing this by hand, but AI can look at this information and scale that discovery in a way that we humans can't, right? Algorithms, digital algorithms, digital intelligence can look at data in a way that we can't. And what this can do is it can speed up this process, this pipeline from basic research to clinical trials, all three phases, to the review process until it finally becomes a medicine that can save people's lives. So let's talk about specifically how this would work, technically speaking, right? Let's not just talk about buzzwords. How would this work? So let's say we have a genetic database. For gene therapy, we would be using a genetic database. In the case of, let's say, cancer, which I think is the most exciting because this is a major unsolved problem, we would have a list of a data set of possible drugs that could be used to treat whatever cancer you're trying to treat. And the idea is that how do we find the needle in the haystack? In that, how do we find the one that sticks out from the rest that's going to be perfect for this specific disease that we are targeting? So that would be a discriminatory problem. We are trying to discriminate amongst a bunch of potential drugs to find which is the one that could cure the disease. But what would be more interesting is instead of framing it as a discriminatory problem, we could frame it as a generative problem, where we're trying to generate the cure by using the existing data set and applying some sort of distribution to it. So what I mean by distribution is we take that initial data set and we think of that as a bunch of ones and zeros. So in machine learning, we think of this input as a matrix. And what a matrix is it's just a group of numbers. It's a giant group of numbers. It can get big, it can get as big as you want. And we take this group of numbers and then we apply a series of multiplication operations to it. That's what AI is. It's a series of multiplication operations until the initial input, which is a group of ones and zeros, becomes an output, which is a different group of ones and zeros. And from those ones and zeros, this translates to a drug, right? So think about it, the byte and the gene, DNA, blood, the basic building blocks of life. This is information. So we are using information that we create with electronic equipment to find the information for cures to diseases. And so if we frame it as a generative problem, we can generate new types of drugs that would cure potential diseases. In particular, a model, an algorithm that I find to be very promising in this field they're called generative adversarial networks. And the idea behind these networks is that we have two competing models. One is trying to generate new candidates for a drug, in the case of drug discovery. The other one is acting as a discriminator, and it's looking at this, what it outputs, the group of ones and zeros, and it's saying, is this a cure or not? Is this valid or not? And so these two models play a game where one's trying to generate a cure and one is trying to discriminate whether it's valid or not. And that's a very high-level idea behind these two mathematical models. By the way, all of this is math. All of this is it's just math. It's matrix math. That's it. It's nothing. It's not more than that. It's just math. And so people need to understand that when we're talking about, this is a bit of a tangent, but it's a necessary tangent. If we're talking about AI and apocalyptic AI and all this stuff, we're talking about the potential for humans to use math, specifically matrix math, to either exploit other humans or to help other humans, empower other humans. That's the issue, is humans. It's not matrix math. It's not AI. AI is just matrix math, okay? So that's a tangent. Back to this. So generative adversarial networks, they play this game, generate, discriminate, And I think this is a very useful model to use in the field. And so in this hackathon, I'd like to see people try this out, right? So this is readily available. I have several videos on this. There's a bunch of free tutorials on the internet about this. So if you search GAN tutorial, healthcare, a bunch of great tutorials are going to come up. So that's the first application that I'm very excited for, because there's so many people who have been affected by this. I in particular, I have someone who I care about who has been affected by cancer. And so it's both a personal thing and a general thing as well. So that's a very exciting one. The second one, automated diagnosis. So if we think about the process that a doctor uses to diagnose a disease, they are using their 5 senses. They're using their human vision, biological vision. They're using their sense of touch, right? They're using their sometimes even smell, different things like that. And so to try to diagnose what a disease is, and again, this is a discriminatory problem. They have a set in their head, in their biological intelligence, they have a set of potential diseases that this could be, and they're trying to discriminate based on the input data, right? What diseases could be. And so if we frame it like this, the reason I'm repeating this is because we have to frame it as all of this is just information. Healthcare, it's all information. Digital, genetic information, it's all information. And so if we think about that process, how do we automate this electronically? And how do we help doctors, help make their lives easier? This is not something that will replace doctors. It could if we want it to, but if we frame it as how do we aid doctors and make it so that they can scale the number of people they can help, then this could be a good thing for doctors. And then this could be something that doctors would embrace. So one example in particular, radiologists, right? So radiologists, most of their job, 80% of their job, is to look at these images and use their biological vision to try to decipher whether or not someone has a particular disease. AI has now been proven to be better objectively than radiologists at this. What a radiologist could do with this technology is they could scale the number of people they could be treating at the same time. In a lot of countries across the world, there's not enough doctors to treat the number of people there are. So this is just a scaling technology for doctors. That's one thing that it does. So automated diagnosis, we're using convolutional networks. Convolutional networks are a type of, again, matrix math combination. It's a particular set of operations between that input data. All AI is just a different set of operations for input data. Sometimes you do 3 multiplications and then you do a division. Sometimes you do 2 multiplications and then you multiply it by a specific type of function, right? So it's just mixing up these different operations to see what would be the ideal for whatever our goal is. And in this case, our goal would be automated diagnosis. So the input data in this example here are a series of brain scans for Alzheimer's. And so radiologists and neuroscientists and different types of brain doctors are looking at this manually with their biological vision. But again, this is information. This is information. We can do this better. And so automated diagnosis is something that I'm very excited for in particular. And we can use, again, convolutional networks, which are a type of matrix math operation set that's useful for classifying images and saying what is in this image. So if we have a data set of Alzheimer's images with a label, so think of it as an Excel spreadsheet. One column is just a bunch of images of brain scans, and the other column is just yes or no. Does this patient have Alzheimer's or no, right? So just 2 columns. And using that data set, we give it to a convolutional network. By give it, I mean convert that into a series of 1s and 0s, multiply it by whatever model we're choosing to use, in this case, convolutional network. It's going to give an output. And the learning process here, what it's doing while it's learning, these mathematical models, they have a set of, again, matrices of 1s and 0s that through this optimization strategy, it's updating itself. And by learning, what it's really doing is it's strengthening the connections between different parts of this input image to know what it means to have Alzheimer's. And what I mean by saying what it means is what parts of that image contribute to Alzheimer's. What is the essence of what Alzheimer's is? And it represents this as a series of 1s and 0s. It learns this representation. And so we keep a representation in our head after, if we're a doctor and we've gone to medical school by looking at many, many, many images of this. And so we can replicate this electronically as well. So automated diagnosis is a very exciting application of AI in healthcare. And convolutional networks are just one type of model, many other types of model. And this is by far this is not a solved problem at all. So there's so much, all of these, by the way, we're literally on the precipice of this new revolution of the intersection of biology and information. So it's a really exciting time to be in this space right now. So that brings me to application 3, which is personalized medicine. I mean, like I said, when I got my blood test done and I was just looking at that, I was thinking like, this is data. This is data, all of this is data. And I want this data because I want to help optimize my life. I want to not have to go to the hospital. I want to have this preventative assistant telling me what I should and shouldn't be doing that has my best interest in mind. If maybe, I'm about to eat something and it's like, no, don't do that. You should eat this or something like that, right? So these are just ideas of how this could work. But the idea behind personalized medicine is doctors are expensive. Not everybody has access to a doctor. So if we can automate the whole diagnostic process into a personal assistant that everybody has on their phone, and everybody has a phone, and everybody will get a phone as the cost of these machines drop drastically. 8 million people will come online this year, which is very exciting. They're going to have access to personalized medicine. If we can put this technology, again, this set of matrix operations, mathematical operations, onto a server that they can access via a website, upload their information, and then they have their own doctor in their pocket. So that's super exciting as well. Our goal as an organization, as School of AI, is to help solve the 17 what are called Sustainable Development Goals, which I'll talk about at the end. But this is a big one. This is one of the Sustainable Development Goals outlined by the United Nations. So there's one more I want to talk about, and that's the most exciting to me. It's also the most futuristic, but that is synthetic biology. So again, the byte and the gene. Genomic data is really interesting. There are so many applications to create new types of, not just gene therapies. When we think about genetics, we think about generally, we think as the public, we think about using genetics to try to fix some problem that we have. But what I think is more exciting is not gene therapy, but gene enhancement. What if we could use our genetics to create some new type of drug that could increase our intelligence by orders of magnitude? And by intelligence, I mean our ability to learn. Children are much better learners for language than we are as adults. But we can replicate that as adults. What if we could be like sponges and learn, Mandarin in a week with this new type of drug? So superintelligence is something that I would be really interested in. New types of gene enhancement, not just intelligence, but endurance, reversing aging. These are things that sound very science fiction, but again, there's so much possibility when it comes to combining biology and information. Another one that I find in particular very exciting, I was just on the plane and I watched 5 movies because it was such a long flight. One of them was Jurassic World, and I was looking at the idea, and I was thinking in my head, I was like, okay, in this movie, these scientists found this sample of DNA and they reconstructed a dinosaur from it. But the reality is that the half-life of DNA is something like 520 years, but dinosaurs were around 60 million years ago. So all of that DNA is gone now. And so a lot of leaders in that space have said that, we just can't do that because the DNA is gone. But what they haven't thought about is using generative models, not necessarily use that DNA to add different, splice in whatever's missing, but to completely regenerate that DNA from scratch, using the DNA that we already have from genomics data. So think about it as reverse engineering what their DNA would be from the existing DNA that we have. And so yeah, we could have Jurassic Park be real. I think it's possible. So I hope to see a startup like that at some point. But also, synthetic biology is very interesting. It's super, like we haven't even begun to think about the possibilities of, say, molecular computing. I mean, that's kind of out there, but DNA can store something like 200 terabytes. I'm just kind of guesstimating here, but like a lot. Like a single strand of DNA can store and does store terabytes and terabytes and terabytes of data. And if we could somehow modify DNA to both store data and to process data, we wouldn't need these machines, these phones in our pocket anymore. They would seem like ancient, and they will in the future. And by the future, I mean hopefully in the next 20 years or so. But using DNA as not just data, but as a mode of computing and for storage is wildly exciting, because think about deep learning, right? So in 2012, that's when the deep learning revolution started, of using these 30-year-old models all of a sudden they just became amazing at image classification, all of these other tasks. And the reason for that was because we had better compute and more data. Those were the two reasons, right? Because we have better compute and more data, these ancient, not ancient, in terms of computer science, they're ancient, 30-year-old models all of a sudden worked really well. So imagine if we had computing that was orders of magnitude better than the best GPUs and TPUs on the planet, then we could use these existing models and have, again, a whole new revolution. So something like molecular computing and molecular storage has a lot of potential for creating an entirely new paradigm of computer science and opening up an entirely new paradigm of algorithms and possibilities. And all of this comes from, again, the intersection of the gene and the byte. By the way, if you want to learn more about this, the gene, the byte, the atom, I didn't make this up. This came from a book I read literally called The Gene by Siddharth Mukherjee, who's an oncologist. So definitely read this book. It's a great book. By the way, this is going to be super useful to you, like outside of all this. What I do when I read is I read books by listening to them as audiobooks at 3x speed. And so in the past 6 weeks, I've read 13 books. And so what I do is I just kind of like sit there, I'm listening, I'm not really doing anything, I'm just sitting there. And I'm listening, and I'm absorbing the information. And I've said this on my channel, on my YouTube channel, but a lot of people were skeptical. But even now, I'm getting people who are saying, Siraj, you don't know how much I'm learning now. Like, I was skeptical that I could do this. Like, 3x is way too fast. And I'm not a native English speaker, and you are, so I can't do this. Well, guess what? A lot of my subscribers, primarily from India as well, are able to do this now. Not a lot, like I got 3 of them like tweeted to me that they could, which made me very happy. So you gotta work up to it. It's like you're lifting weights. You're not gonna be. I couldn't do 3x when I first started. I can only do like 1.5 max. But if you start at 1 and then go to 1.5 and do that for like 2 weeks, 3 weeks, your brain, your neurons, your connections, they're gonna update. They're gonna strengthen. And I see someone shaking their head. No, this is real. This is real. There's still so much skepticism around the possibility of this, but it's a real thing. Try it out. Don't take my word for it. Try it out yourself, and you'll see. But this is a great way to take in a lot of information. And until we get to the time where we have devices and maybe gene enhancements that help us accelerate how fast we can learn, this is a great midway point. Like listening to things at 3x speed. Video as well, I do that, even my own video. So these 4 applications, they're a part of our mission to help solve these 17 Sustainable Development Goals outlined by the United Nations. So the idea is that these are very ambitious goals, and the United Nations outlined by 2030, which is actually like only 11 years away. It's pretty ambitious. They want to solve all of these: no poverty, 0 hunger. These are very ambitious initiatives, and we at School of AI believe that with this AI technology, using the massive data sets that are available to us on the internet today, that anybody anywhere has access to, regardless of where you're born or what your profession is or what your schooling is, you are able to make an impact with this technology. And we believe that with the combined effort of the globe put together, people from across the world, from different cultures, different viewpoints, different perspectives, if we put this together, we can come up with these incredible solutions using this technology, and we can accelerate the progress towards these goals. And our goal in particular is to make these happen by 2025, not 2030. And once we do that, once we're able to solve these goals, what that means is for the majority of the world, as everybody comes online, and everybody will be online within the next decade, all of humanity, mostly like 99%, is going to be online. And then we have an entirely new internet culture. When this happens and everybody's basic needs are met, then we can get to the stage of creativity and innovation globally. And it's just going to build on itself. And we're just going to accelerate and accelerate and accelerate. It's a very exciting time to be alive in human history right now, when we have the potential for these technologies to solve these incredibly hard problems and enhance our way of life, improve our lives, improve our relationships with people, and improve just the way we act in the world and how we know about all the complexity in the world, simplifying it such that we know exactly what to do, when to do it, we're more confident, we feel better about ourselves. Just overall, we're trying to increase the well-being, the health, the intelligence, the emotional intelligence of humans using this technology, and we very much think it's possible. Thank you.
So now I'd like to introduce you to our panelists. So first up, we have Aisha Khanna. So Aisha is co-founder and CEO of Ado AI, an AI solutions firm and incubator. She's advised governments and corporations on AI, smart cities, and fintech, and she's on the board of Infocom Media Development Authority, which is the government agency behind Singapore's Smart Nation vision. Aisha has a PhD in Information Systems and Innovation from the London School of Economics, has written 2 books and multiple articles on technology and innovation, and has been named one of Southeast Asia's groundbreaking female entrepreneurs by Forbes magazine. Thank you for joining us today, Aisha. Next up, we have Dr. Victor Tong. Victor is the Chief Digital and Information Officer at the National Gallery Singapore, where we find ourselves today. He was the founding director of A-Star's Social and Cognitive Computing Department and the head of Biomedical Informatics at the Institute for Infocom Research. He's also held senior roles at companies like Pfizer and SAP Research. Victor has a PhD in biochemistry from the National University of Singapore, and his work has won numerous awards, including the MIT TR35 Award and the World Economic Forum Young Global Leader. Please welcome Dr. Victor Tong. Next up, joining us is Charles Cruspeyre. He leads Accenture's artificial intelligence practice in Southeast Asia. He has over a decade of experience in AI across industries including fintech, advertising, security, and the military. In the past 6 years, Charles has founded 2 AI startups, one focused on predictive maintenance for the oil and gas industry, and the other on fraud detection and credit scoring for unbanked populations. So please welcome Charles. And last but not least, we have Dr. Tan Tin Wee. He is the CEO of the National Supercomputing Center in Singapore, where he manages Singapore's first petascale supercomputer. He was also the founder of the Bioinformatics Center at NUS, the Asia Pacific Bioinformatics Network, the first internet service provider in Singapore. He founded and oversaw the creation of the multilingual internet domain name system, and Wired magazine has called him one of the people who built the internet. So please welcome Dr. Tan Tin Wee. And of course, we'd like to invite Iker and Siraj again to join us up on stage. And our first topic that we're going to be talking about today is ethical AI. So that might seem a bit vague to people who are new to this question. So maybe one of you can make that more concrete. What are we talking about when we're talking about AI and ethics? Is this like Alexa and Siri getting together to rob a bank or something? Like what is the problem? And just grab a mic.
Maybe I'll make a head start. I guess maybe a way of putting the problem is when you look at the way traditional software programs or software systems or capabilities are built, there is a very easy way for us to explain the decisions that are taken by that software. There is a deterministic link between the input and the output, right? The moment we perhaps put artificial intelligence into the equation, such link gets a bit more blurred. And the decisions that the system are making in the context of a classic example that comes to mind is autonomous driving. So 2 autonomous cars are going to be in an unavoidable collision. Does the system have to make any decisions that affect who survives or who doesn't survive, for example? What are those considerations that are going to be taken into account? How do those decisions get taken? What are the parameters? What are the outcomes? Why do we take the decisions we take, and how did the system reach the conclusion? That's perhaps one way of starting the topic.
Does anyone have a differing opinion? Is that the problem? Is the problem of inscrutable AI models that do things we maybe can't take responsibility for?
I mean, that's definitely one of the problems. I totally agree. I think that one can kind of divide it into 3 problems. One is explainability, which is even for AI engineers, sometimes it's hard to understand why it actually came up with it. Then it's interpretation, which is for the business user or for the domain expert who's partnering with the AI engineers. And the third is ethics. So are you comfortable with what it's doing? And in ethics itself, there is 2 ways. One is, I think, when you you don't create algorithms that are deliberately manipulative, such as all the deep fake algorithms and the potential over there, that you keep your data processes, lineage, and transparency in order. Those are some of the recommendations by IMDA's framework for ethical AI. And then the third is trying to really establish global ethics and then, I guess, cultural ethics. I mean, different countries may have their own limitations, may put out their own limitations while others may not. So if you look at GDPR, I personally think it's a really good standard for the rest of the world to follow because it really puts human rights as data rights or data rights as human rights right at the core of how we approach algorithms.
So is there room then for research in AI to teach us more about global ethics or cultural ethics or what we want those things to be as a society?
Well, I guess a bit of a tough question to pick, but I guess a way of looking at it is that the fact that AI exists and is something that is totally unavoidable, I guess it puts the spotlight on those questions and it is going to force that conversation to take place, right? Maybe in a more elevated or intense way that it has been happening so far.
I mean, I think the dumb way to do it is to get either a bunch of lawyers as policymakers or to get all like engineers together. Whereas we really need to have a diverse team. We need more people who are philosophers or artists or people who come from different domains to get together. This is literally something that's going to impact society and economy to such an extent that perhaps it's even rewiring our social contracts with the government and with corporations. So it requires a more diversity in the people who address it.
Totally agree with that. Yeah, that's a great point. And that we need more diverse, a set of people other than engineers making these very important decisions that are affecting all of us that use, for example, social networks. Facebook is the easiest example to make fun of because of the amount of industrial scale manipulation and exploitation that it does in the name of its business. And so Facebook's newsfeed, for example, it's like my favorite algorithm to trash, basically, because Facebook's newsfeed is an example of a runaway AI. It's making decisions that even its creators don't understand at this point because of the amount of data that it's using to show you what it thinks is going to maximize your attention. So their business model is ads, right? Are ads. So it's the revenue they get mostly are from ads. And so the longer they keep your eyes on the screen, the more money they make. And this is bad because if we look at a lot of studies of children who are using social networks a lot, it causes anxiety and depression. This is a proven thing. It's not just a fake thing. So being on social networks too much is objectively bad for your mental health because mainly it's optimizing for your attention, whereas ideally it would not be optimizing for your attention. It would be optimizing for your time well spent. What would benefit you the most? What is the content that would help you with whatever your objective in life is? What would be educational? What would not be violent, but instead promote cooperation and empathy and things like that? And we're not there yet because we just built this system and we just built this billion-person plus scalable AI algorithm and trained it on maximizing attention. But maybe in the next phase, we're going to clean up what I consider to be digital pollution and instead make it cleaner data, cleaner information that is going to optimize for your time well spent. And I would encourage you all to look up literally time well spent because this is an actual movement.
I think at the end of the day, it proves also something is that many of those concerns were existing pre-AI actually. If we talk about credit scoring, another type of application, well, if you consider putting the location of an individual into a decision-making system, it is not fair because it's not because you're living in a poor neighborhood that you're not someone trustworthy. And yes, this is a problem that is being raised with AI, a concern, but does that mean that it was not existing before? So maybe at the same time as we're working on those frameworks for the AI, something even on our humanity, something to consider also, because at the end, it's kind of replicating a lot of the things, even regarding Facebook feeds. Well, Facebook feeds is only replicating what TV channels are also doing, trying to optimize the revenue in a certain way because with easy-to-eat content. So that's I think it's a great question to ask, and it's not only concerning AI; it's a society issue here.
Yeah, that's a good point about these being pre-existing issues. There's this now very well publicized phenomenon of judges sentencing more harshly right before lunch than right after breakfast, and so that's the same kind of bias that you can get with humans that you could get with machines that are trained on bad data, or that without those notions in mind very carefully.
But here again, we have also to be careful. Correlation versus causation, because if you take numbers like that, we had this conversation with my team earlier this week. You can have a statistics that tells you that you have more murder when you have more ice creams being sold. So we also have to be careful on those kinds of
right, because of the heat and stress. So Aisha and Siraj, you were talking about that we need more people. This is more than just a problem for engineers or lawyers. And we need more diversity, and this is something that's going to affect everyone. So maybe Dr. Tong, you can tell us, what do you think is an institution like the National Gallery where we are here? What is the role of such institutions in helping educate the public and helping ensure that we see the more positive sides of those results than the more negative ones? Do you see that institutions like the National Gallery have a role in that?
Well, I guess for National Gallery, we are looking at the application of AI to improve or optimize our process. So we do not really go into the aspects. But I guess a fundamental problem when I talk about ethical AI, it regards about the cultural differences in which, for example, may be different across different organizations or even across different segments of society. So how do we actually reconcile all these things? Because when I talk about ethics, if the ethics refers to has different meanings to different populations or to different people, then how do we actually get everyone on board to agree on certain sets of principles or codes of practice?
Yeah, and I suppose that's another one of those problems that exists before AI and will exist afterwards. So maybe we can transition now to the topic of healthcare and some of the implications of AI for healthcare. We talked. Siraj talked about the impact of AI on radiology in particular, and the potential for personal assistance and stuff like that. What are some of the areas where we're starting to see impact of AI in healthcare or in bioinformatics or any of those areas right now?
Well, I think most of the things have been brilliantly covered by Siraj earlier. So please refer to what have been said before. But I think in general, we can see that AI is helping at predicting what's going to happen next, being able to detect slightly before a doctor first signs of any kind of cancer, any kind of health issue, being about optimizing. This is where it brings a lot of value, is assisting doctors, but also assisting you in trying to predict and smooth up the way you live in order to optimize.
So you get the average person gets superpowers, essentially. It gets medical superpowers.
I don't know if it's superpowers, but it's statistical knowledge about, okay, if I do that.
Statistical superpowers.
So
I think adding on to some of the comments that Siraj shared earlier on cancer being one of the key applications here. If you look at the study, I think a lot of us have experienced this in our families and in our relatives. It's a very complex journey for the patient, and a journey that has a lot of different stages, and in which, when you've gone through that journey, you can clearly see a lot of aspects in which artificial intelligence can really play a role in helping early diagnostic. For example, certain types of cancer has proven to be the difference between survival or non-survival, right? So having that radiologist being able to detect, with the help of that perhaps superpower of having those supercomputer eyes that are helping detect something in its earlier form that is totally opaque to the human eye, that would be the difference between life and death for so many people. One of the situations I experienced in this particular case was when a patient goes through chemo. You clearly tell that there's something different in that treatment to anything else, right? Secondary effects.
collateral effects of the medication they're giving you, they would give you a list. These are the known things, and that could or could not happen to you. This is the phone number you call when you experience anything else, so we can learn from it. Now, you think about that, right? That sounds like a space where artificial intelligence can start gathering all that data, and we can continue to learn from that. And it's a disease that puts us all into the unexplored territory, perhaps. So one where definitely we can see some application there.
Well, Siraj has given a very good overview about the use of AI for drug design. So, for example, what I can touch on is on vaccine design. So, in the early days, vaccine, we look at using dates or weak virus as a means to trigger immune response. But in new generation vaccines, for example, scientists have been using AI, predictive AI, to identify regions of the viruses that can trigger T-cell response. And so many of these are new kind of vaccines, for example, HIV vaccines, multiple sclerosis vaccines, and bird flu vaccines. For example, these are undergoing different stages of clinical trials, some in phase 4 for HIV, and phase 2 and phase 3 for influenza virus vaccines. So these are some of the potential applications that AI can be used for vaccine design and also for drug design.
So I just like to comment on the importance of the school organizations like the School of AI. There's a lot of education that needs to take place before the healthcare community can actually latch onto this extremely powerful technology. Of course, as with a powerful technology that comes with great responsibility and a whole spectrum of ethics that has to guide us in the way we apply these incredibly powerful technologies, and in particular AI, which has the capability of surpassing human intelligence. And also this possibility that an artificial thing that is divorced from human consciousness, that is able to now predict things far better than anybody, the so-called superpowers that you describe. And so it's critically important for us at this juncture of time for us to really look at this incredibly powerful technology and put in place an educational process that will help us understand what are the things that we can apply AI to and what we shouldn't be doing, right? And these ethical issues that arise touch to the very core of us as human beings. Human beings are conscious of, and we are moral creatures. And therefore, if you envisage an artificial environment where a machine that does not have consciousness now has super intelligence, then that difference now starts to create a lot of impossible and very difficult situations from day-to-day activities, like deciding if an autonomous vehicle were to crash, should it crash this way or that way? And you've got to make that value judgment in making a pronouncement of a cancer patient as to what sort of treatment he has to take, or that's the end for you. Is it ethical to tell a person that, I'm sorry, it's incurable, it's the end, you have no hope? That robs the person of all hope. But the intelligence says, yeah, it's correct, it's a fact. Do you want to say that to a person? Is it ethical for you to say that to a person? So it's important now for us to understand as human beings with morality and consciousness that we are venturing into a scenario where we're talking about artificial intelligence, artificial super intelligence that probably is smarter than all of us at this stage. And it keeps learning. Whereas human beings, we are all born clean slate. And we need education now to bring us to the point where we are smart enough to be able to have this conversation. So that brings me right back to why the School of AI has a very critical task to play, particularly in the healthcare community. I'm 29 years, 19th of February, at the School of Medicine. Okay, so you introduced me as being an internet pioneer. Well, I'm a professor in the biochemistry department. But in the last 30 years, I've been trying to introduce bioinformatics. And along the way, no traction, so I did sideline projects like the internet, like supercomputing, like multilingual domain names and so on, and I gained significant traction there. But in my department, in my school, it's still a long way to go. And that's the medical school. let alone the entire establishment of the healthcare system. It takes a long time. So even as we are really excited, and I'm a technology guy, right? And really excited about technology, but never underestimate how long it takes for us to actually educate people, change their mindset, to adopt technologies in an ethical manner.
Yeah, that's really interesting. Yeah. On that topic of how it's been taking a long time in the areas that you're involved with, is there something specific about healthcare or the healthcare industry that makes that the case? Where, for example, as Siraj mentioned, a lot of these techniques are based on academic papers that have been published for decades, and the research that goes on today, especially championed by organizations like OpenAI, is out in the open, and research is out in the open. Does that fit well with healthcare? Does that kind of does the open source philosophy fit well with healthcare, or is there some other reason why maybe things it's taking longer, as you said, for that adoption to take hold?
A lot of healthcare data is private for good reason, because it's very sensitive data. And so people working with healthcare have to find a way to get this data, finesse their way to having access to this data. But what I think is a great startup idea, that it's one of many, but if I had the time, I would be working on this. But what would be a great startup idea is to offer a service to these hospitals and other healthcare providers that offers to anonymize their data and sell this anonymous data directly peer-to-peer to trusted entities that they vetted. So that would be like anonymized data as a service, ADAS, anonymized data as a service for healthcare. So if you can prove to these, and that's a great kind of startup to do on the ground, because you can physically go to these offices and work your magic and try to sell this idea and just build your repertoire and trust over time. But if you could do that, then all this anonymized data would become more publicly accessible to people.
So Siraj, you talked about your vials of blood you donated, right? You actually gave it away. And the data that's associated with it and the metadata that's associated with it is actually held in a database somewhere in the hospital. And the data belongs to them. You don't get a copy. You might get download a CD nowadays. They give you a CD of all your scans, right? But that's just about it. Until the medical information of a patient now belongs to me, myself. It's a long, hard road. Because right now the medical profession keeps that information, and for a good reason. Privacy issues, for example. In Singapore, we have had a recent spate of loss of medical information, and by the millions. And the whole issue about what's my private medical information, and how it impacts on me, myself, to my family members, or more importantly, perhaps, my insurability, right? How would the insurance agents now assess the amount of premium I have to pay if they knew that I was suffering from this or that genetic disease, or my propensity towards a particular cardiovascular event, and so forth. And with super intelligence, you could almost predict to a certain very high percentage of accuracy, statistical albeit, whether I'm going to develop this or other disease, and will my insurance premium exceed the point where I become uninsurable, right? So these ethical issues now, and possibly even a lot of the legal issues now, become entangled and entwined inextricably with all these powerful technologies that we are trying to promote here.
Yeah, I think that's a really good point. It's one thing to introduce AI to medical students or to hospitals, but actually it's as important to introduce it to lawyers. They need to study this as well, or business students. And what my company does is we work with a lot of large enterprises in Asia to introduce and build AI solutions for them. And we see a lot of resistance in the beginning because of politics, inertia, all of the usual things, and this idea of privacy that is not even technically sound sometimes, just because they don't even understand whether something is available or not available, or is truly protected or not. And I think everybody is just afraid of their own jobs. They're kind of afraid to take this first step. So making it easier for them with some kind of repeated pilot or proof of concept, as a lot of companies are trying now, and the Singapore government is subsidizing, I think is a good way forward. And we need to get all small, medium enterprises that are 70% of the backbone of this country, we need to get them some basic education and then access to the cloud and access to software that they can upload their data in, and begin to see some returns on investment. I think that's one is the education sector and the other is the business sector really seeing some return on investment. The problem is they all expect something they saw in the movies. I mean, there's so many times when my team will write, we'll write some predictive algorithm, and the data wasn't good, it was dirty, blah blah blah, and then we're like, thank God we got like 70%, it's amazing, and then they're like, 70%, not 99%. And it's like they're obsessed with this 100%, 99% number because they've been going to too many movies or looking at Wired magazine. And I think that they need to know it's a process. And all of those things are really important to keep in mind when you're trying to introduce it. Obviously, I'm very interested in seeing how to introduce it to businesses as well as to students.
Yeah, I'm really interested in that obsession with the 100% thing, because that's something I've come across as well. Maybe this is a bit of a distraction, but let's see if it strikes a chord. So I'm personally interested in self-driving cars. And whenever I talk to someone about self-driving cars, they say, well, how can you make the self-driving car perfect? And I'm saying, well, I'm not perfect and I can drive a car. Like, why are we not asking that question about, like, how can I make sure that you're perfect at driving a car before I let you drive the car, right? So why is it that our expectations of the software that we build is perfection, whereas our expectations of ourselves is like, as long as we're meh, it's okay?
I think it's very related to the hype curve we see whenever a new technology is introduced, right? There's always like this typical curve of, there's a lot of hype, becomes a buzzword, everyone wants it, everyone expects the world out of it. Then there's this disillusionment when you realize that 100% is not going to happen, but you may get 70, and eventually we get to the point that, 82 is pretty good, right? And I think if you look at all the applications we're seeing, I really like what you just said on the introduction and the fear or sort of the apprehension. I think it's a journey and probably parallel to the journey to the cloud as well, as an example, right? Probably an easier one to understand. A lot of companies in different degrees in every industry are moving to the cloud, and are moving to the cloud as a journey in which as they understand the risks and the advantages, they feel more and more comfortable moving more complex, more critical workloads to the cloud. And I think artificial intelligence is just a journey that we see happening a very similar way. And we have a lot of projects in which we are helping implement the famous chatbot, the famous customer servicing capability, which is very low risk. Nothing really critical depends on it. You can just make someone a bit happier. You remove friction from a process. Moving into using computer vision to automate a lot of activities, but inherently lower risk tasks, right? But we're starting to see some traction in places where people are getting more and more comfortable exploring, putting critical parts of their business in the hands of artificial intelligence. So I guess it's a journey, as you introduced.
So people just have to get comfortable with it.
Yeah.
Like a pair of shoes. The artificial intelligence.
So Victor mentioned about computational design of vaccines, for example. So recently you heard that our zero tolerance for any drug vaccine that we take, right, requires 100%. You are asking about 100%. Why is this? It's important to us. If I have a child and I have to decide whether it's going to take this vaccine or not. So that has resulted, say, in the US, where a lot of people are against these vaccinations because they are afraid that it could be leading to all kinds of ailments, like including autism and so on, backed by arguably fairly tenuous facts. But if there is a risk that my child might get, I might say no. But result is recent outbreak of measles, for example. So how do you balance that? So this is where all these serious ethical considerations and legal issues as well, and whether the government wants to put in a law that says no, for the benefit of the entire community, we are happy to have 1% of people suffering the potential negative effects. And that computes to quite a large number. If you have 1 million people and it's 1%, that's a heck of a lot of people, A heck of a lot of children that will be affected by it. So you got to weigh it against the public health issues versus the lack of 100% efficacy of anything. So these are things that I doubt if any AI system can eventually grapple with. Maybe AI in the ultimate AI ethical system, but that will be another story for another day. But so it is critically important for us when we talk about AI in healthcare that we take this into consideration and really think through the whole process of how we go about introducing AI in a measured, calibrated, and nuanced manner in healthcare.
Do you have an idea for applying AI to healthcare? Let me know in the comments section, and please subscribe for more educational videos. For now, I've got to find a float tank, so thanks for watching.